So now that you know what Android Wear is and what we should be doing with wearables, let's talk about how you can get into the development and actually build an application. My name is Chris Black. I'm a software engineer at Nov19. You can follow me on Twitter, and my GitHub has a number of examples related to Android and Android Wear. But really, before you build an application, you should understand the different types of wearable apps. If you look at Android Wear as an extension of your phone and providing the user with various functions or gateways into your application, there are a number of different ways you can go about doing that. And taking a look at what you can do is really important before you actually start prototyping or building out an app. It can also help decrease the barrier to entry if you realize that you could do something as simple as improving existing notifications within your app instead of having to build a fully featured self-standing application on its own. I actually just wrote a blog post today that I think will help whether it be sales or product owners understand the different options they have for Android Wear or even Apple watches. So it's kind of platform agnostic and talks about the different types of things you can do and the different stages you go through when you build an application. So during my presentation, we're going to go through some code samples for the very early stages of Android Wear, the stages that you don't even need a Wear application running on the watch. It's something that you can actually drive completely from the phone. And given the way that Google has written the APIs, you can do that very easily. And Apple and the watch kit that they've released, I believe that you can do very similar things with that as well. So they're very smart when they built the watches. They made them useful out of the box. They present notifications to you, and in most cases, they're very simple. They're just, this is an email, this is a text message, you're getting a phone call. You can take a look at the weather, and that's an example of a very simple notification where you're not really doing anything other than glancing at it to find out an update in your life, so you don't have to pull out your phone to check these basic functions. The next stage of apps, if you want to get a little bit more complicated, is to add voice integration. So now you can take that to the next level. You get a text message, you can reply back to that text message. Or you could take a note on your phone. Getting even into more detail, you can actually build an application that resides completely on the watch. So the next step, if the first two things don't complete your goal or business need, you can actually then build out a fully featured application running on the watch to monitor different things, to send information back and forth between the phone, or to run completely independently on the watch. An example of that would be a watch calculator. And then you can send data, so you could record footsteps, you can record sleeping patterns, various information, and transmit that to and from the watch and the phone. So we're going to start very simple, notifications. This is something that will generally work out of the box, but might not look the way that you want it to. And to me, this is the first place that everybody should start when building applications for Android Wear. It's easy to integrate. You can use existing APIs, just sending notifications to the watch and making sure that they look good. This is the first step that everyone can take to integrate into their existing apps right away. So with just notifications, if you want to stick with just the text and title and icon, you do not need a wearable APK. You don't need to build out a separate app. Nothing needs to be running on the watch. You can just send the notification straight to the phone, and you have a lot of control over stacking those. You can have actionable items tied directly to these notifications that appear only on the watch. There are a lot of different things and unique things that you can do with notifications right out of the box. You can have multiple pages of content. So if you have more than one thing to show, like with the weather app, where the first page is the current weather, and you swipe to the right to view the weather for the next 5 days. So the prerequisites for this, sent out an email. And don't worry if you aren't able to get everything set up. as I'm walking through this. That's okay. There's a lab period at the end of the presentations where we'll walk around and help you get set up and make sure that everything is good to go and answer any of your specific questions. But if you've got Android Studio set up with all of the SDKs and everything ready to go, go ahead and open that up now, and you can start playing around with the demos as I go through them. So you need the latest everything. Right? And I'm not joking with this. If you don't have the absolute latest of everything, it doesn't work. And up until just a couple of days ago, the timing on this was perfect, because up until a few days ago, none of the Android Wear demos that they had packaged with the SDK even worked well with the current version of the Wear SDK. They are all referencing the beta versions, and the rollout for this has been a bit of a mess. I think that they definitely compromised on quality to get to the market first. And there are some advantages of that, in that they're the first to market, they get to kind of test the waters. Apple gets to benefit from that. But they've got a full iteration and time to improve and roll out Android 2.0 for Wear, all before Apple will probably hit the market. So there is some positive behind this. But again, 3 days ago they updated all of the examples. All the ones that I tested work out of the gate. They have images that you can look at that show demos of what the application will look like. There are descriptions. It's what they really should have launched with back when they launched everything at Google I/O. Again, you need everything. You need the Wear SDK in addition to the Android SDK. Yep?
What's the Wi-Fi situation here?
I connected to the guest Wi-Fi.
Guest Wi-Fi should work?
Yep. And then it'll pop up a window and you just have to accept the terms and conditions of using Wi-Fi here, and you should be able to get connected.
Okay.
So the first exercise is creating a notification. And this should look familiar to anybody who's done any work in Android with notifications. You can actually dispatch a notification directly from your app, something that you would also get if you did a push notification to the phone. I'm going to pull up Android Studio. Of course, nothing is. There we go. And I'll pull up that link again real quick before we dive in, just so everybody can get it downloaded if you want. So this is a link to the GitHub page where I have the example code that I'm going to be walking through. Again, you don't need a Wear activity. You're just going to build, if you're doing this from scratch, you're going to create just a new Android application. You don't need to check any boxes with Wear or anything like that. Now, you're able to just create a notification using the support libraries. I'm going to walk through this real quick. It's just got a button on the screen. You tap the button and it dispatches a notification to the watch. It's very simple, but a good first exercise, and in most cases this may be enough for your application. We're going to scroll down to the on create, and with this you inflate your activity, you assign your button, and then you add the click handler to the button so that you can actually dispatch the notification when it's clicked. It opens up the notification on both the device and on the watch, and that's really all you do to start with. So to demo this, let me see if this works. I've actually got a webcam that I'm going to attach to my head. I've done this before, it works. Trust me. So I'm going to set this up. And I can show you how this works on my phone and watch.
Bluetooth, right?
Bluetooth. Watch and phone. So this is the camera. I've got a headlamp that I have attached to. When I was demoing this, it was appearing on my screen, so this is going to be a little bit different having it appear up there versus down here. Just make sure that the contrast looks good. Alright. I'm going to bring it over here just so I can get this configured. Alright. Notification. Right. Tap for notification. Appears on the phone. Everybody can see that okay? Yes? Alright, perfect. That's as simple as it gets for the first example. I'm going to show you what the second example is going to look like while I've got it all set up. The second example is adding voice command to the notifications. So we're going to try the notification. Light on at home, turn it off. You can tap reply. Hello world. Never lie. It sends it back and appears directly on the phone. Alright, again, how was the quality on that? Everybody could see what was going on? Alright, perfect. Alright, so exercise number 1, creating a notification. So to get started with that exercise, again, update all of your software. And then to test this out, the majority of you, if you don't have a wearable device, are going to want to create a virtual device on your computer. So to do that, we're going to run the application and create a virtual device just as you would on, like, for a phone. And this is where it's important to have the Android Wear SDK installed. The other thing that I found out was that in the SDK manager, the hacks library to increase the performance and allow you to run the faster emulator, if you install it through the SDK manager and it says installed, that does not mean that it's installed. Did a little research and found that you actually need to go into the SDK folder, find it and run it in order to actually install it on your device. So if you run into that, it's a little tip. Just because the SDK manager says you have it doesn't mean you really have it installed. I'm going to show you what the Android Wear emulator looks like. You set it up with basic settings. Finish, and then we're going to launch that device. So we'll give it a second to boot up. The next thing to keep in mind, before you can actually connect your phone to this device, there's a slide. There it is. Every time you start the virtual device, you need to run this command. And what this does is it allows the phone to connect to the watch, and it allows the communication path between the virtual device and your actual phone. So if your phone's connected up via USB to your computer, and you want to connect your phone to the virtual device that you have running, you need to run this command within your Android Tools folder. So once you get the Android virtual device set up on your machine, the next step that you're going to want to do is run this command. able to connect up the phone to the emulator. Alright, so the second demo with adding the voice command to the notification, it actually extends the first demo. If we open the code up for that, we can actually take a look at what that looks like. I'm just going to open it up in Android Studio since the internet appears to be a bit slow. Is there a way that I can just mirror these two displays? Everybody have on Apple?
Yeah.
A quick way to do that?
The displays and then
The checkbox.
Displays and then mirror. Alright, sorry. Preferences, displays. Yeah, displays. Perfect, thank you. Excellent, that makes things a lot easier. Recent. Projects. Right, I'm opening up the demo for the voice notifications. And so what this demo provides an example for is communicating back to the phone with a simple message. Again, we do not need, we don't need an Android Wear application for this. This is still within just the mobile application. So you'll notice in both of these projects that I've got a main activity and then a reply activity. And the purpose for this is so that you can actually open up a completely separate activity when you make that action on the device. So if you tap to open on the phone or if you tap to reply, it then opens up that new activity and sends the data to that activity. You could just as easily create a background service or something that runs in the background that collects that reply or that data or that information directly from the user as they go, so that they don't actually have to pull out their phone and take a look at it. I think that for demo purposes, it's easier to actually visually see something than to have the information picked up in the background. The other thing to note with both of these demos is that they have a very strong call to action on the watch. The watch actually vibrates and the notification is displayed right away. Again, while this is helpful for demoing and for testing, I think that when you actually build your application, you want to keep a careful eye on whether or not the user actually needs to know about this information right now. If they don't need to know right now, you can add more subtle notifications like the weather app, where you can actually update in the background and the user doesn't see it unless they start scrolling through their notifications. So that's something that you're going to want to think about when you actually get to the point of deploying the application. Adjust those settings. But for these demos, it's easier just to see it happen right away and you know everything is happening. So like in the last example, we've got a button on the screen. To create that reply button that you can scroll over to, it's as simple as just this code right here, just a few lines of code where you create a remote input and then you add voice reply. You can even then send it an array of choices and allow the user to select a choice by just scrolling up and picking yes, no, or maybe. So if you send them a notification saying the light is on and they're no longer home, would you like to turn it off? They can scroll and make that selection without having to say something. The advantage for this is if they're on a loud bus or out and about, they may or may not want to actually have that voice call to action. So it's very good to set the reply choices in an array when you build the remote input intent. So then the next step is to set the reply activity or the reply intent. So in this case, we are specifying an activity that we want to open when the user clicks on reply and sends that signal back. We're going to open up the reply activity. And then this is very important. When you create the intent, you want to cancel any current or existing notifications. And so this is something that I think a lot of apps initially are going to suffer from, where you have the concept of notifications in the phone and you just infinitely stack new notifications onto the older ones, and it's just this huge list of notifications. And on a phone you can get away with that because there's just a tap to dismiss all, and the user's not looking at them all anyways. So what you want to do is think about, if I send them a new notification, what should that do? Should it replace the existing notification? Should it cancel it? Should it stack it? And there are a number of different flags that you can set up if you click through and look at the different flags, depending on the use case of what you want to do. So then after you've created the intent, you can create you set up the action builder and you add the action, adding the remote input. Fourth step is to create the notification builder. And at that point you set the drawable, the title, and then this is a builder class, so you can just stack on top of this and you can add a background. You can extend it with your actions, and you can also stack notifications as well. So you can stack cards horizontally so that you can scroll across. So all of this can be done, again, without even creating a wearable app or activity. And then the method that specifies our notification and whether it has a sound or vibration. Using the default of all is going to notify the user in all ways it can. So it's going to vibrate, it's going to contact them right away, and this is where you can specify how you want to notify the user and how you want them to receive the notification. And then make sure that you allow the user to dismiss the notification or dismiss it once it's been pressed. One thing that they've made comments to is if you don't make a way to easily dismiss your notifications, or if your notifications in any way are annoying to the user, what they can do is just check a box saying that those notifications will not appear on the watch ever again. And that's the last thing you want, is to have all this power to be able to notify the user on their wrist and then completely lose it and alienate all of your Android Wear users just because you thought they really wanted to know something that they didn't want to know. Or I actually have gotten to the point where I have almost uninstalled the Pandora app because of how poorly they implement the notifications within Google Wear. I cannot dismiss or get rid of that stupid thing. Even after I stop playing the music and force quit the app and everything, it's always still there. And I think they might have finally fixed that, but I was to the point where one of the few apps I actually had on my phone I was almost ready to get rid of because I couldn't adjust the behavior. So again, with great power, you have a lot of responsibility here to ensure that you're setting these preferences correctly. The best way to do this is to actually use the app yourself. And if you're annoyed, there's a great chance that everyone who uses your app is going to be annoyed. So if you can't put up with your own app's notifications for a week, that's a problem. So you then instantiate the notification manager. And all this code, what I love about this and what's great is that it's easy to set up. There's not that much code here, and it leverages the existing notification platform for Android. So if the user doesn't have a watch, they're still getting this notification. They're still getting all this data. They can still open up the activity on the phone. They're just going to get it through a different medium. So again, as the watch being an extension of the phone, think of it in a way that the watch and phone should match the same behavior in most cases. So they don't need to have the watch. It's just something that will help them and improve the experience. And then when the button is clicked, you then call notify on the notification manager, passing in notification ID, and then the builder. So I kind of walked through all 6 of the steps to create a notification that has a reply button. And this is very similar to if you get a text message. This is basically exactly the same thing. You get a notification, it has a title, it has a body message, it has a background image, it has your app icon for Hangouts. You can swipe to the right and reply directly to that message. So again, this may be enough in most cases for very simple applications and getting going with Android Wear. Any questions at this point before we move on to talk about the full screen activity? And then after I briefly talk about the full screen activity, which is by default what happens when you create a new project and select Android Wear, Brian is going to talk in more detail about the applications and how you can customize them a bit more or brand them more and kind of do more advanced functionality. So the goal here is to be able to open up these projects and have something very simple to start with and play around with when we get to the code lab, and then be able to extend on that and push that forward for what you need later. All right, so we added the remote input, we created the action, added the intent handler, and then dispatched the event with the reply action. So again, straightforward, simple, but very powerful. Full screen applications. So I think this is where you get to the point where you've really got to have a big budget, or in our case, a lot of motivation to really play around with this stuff and create something fun. But in most cases, for many clients, a full screen application is going to be overkill. For most existing applications, unless you really think about, unless you have a specific use case, for example, the timer in the Betty Crocker app, or have a reason to dispatch a full screen application, you don't want to force a client on this, especially as a first step into wearables, because it's a bigger investment and it requires a bigger commitment in testing, in UI, and in creating a good user experience. But this is arguably the more fun part of it, the piece that I started out with, maybe by mistake, where I created an application that runs in the watch, and I can have my phone in my backpack, and it will, as I'm riding my bike, tell me how fast I'm going. So again, very simple app, very straightforward, but I chose to go with a full screen application for that, so I had full control. I could leave it on, I could monitor that as I was biking, and it provided me with that type of a use case. So in the case where you have a calculator or you need a full screen application or a more customized or styled application, you actually now need a completely separate application that runs on the wearable device. It is packaged up with the mobile phone application when you publish it to the market, so the user will automatically get both of those when they download it and put it on their phone. And again, it requires a separate package. You can share code between the two if you want, and you can communicate between the phone and the watch as well. One issue that I did run into when communicating between the phone and the watch, it was smart enough to know that I was sending the same speed of 0 miles per hour while I was sitting in the living room in the chair in front of my computer. And every time I sent that 0 miles per hour, I tried to hit a breakpoint on my watch and would never hit the breakpoint. I was getting really frustrated because it only fired every once in a while. And I figured out that it was because every once in a while it changed the type of data I was sending, and it only sent the information to the watch if the data changed in some way. So if you're debugging or testing, you can add a timestamp to the message, but it's smart enough to know that the display shouldn't change, so why should I send it data and waste that energy on the watch, which is very precious for battery power, when the speed didn't change. So when you're debugging or creating your applications, keep that in mind too, that during debug you may want to put a timestamp or something a counter that always changes, and then remove that when you actually get to production so you're not wasting the user's battery later down the road. So they can communicate with the phone, full screen applications, but they can also be standalone. Like the calculator in no way communicates back to the phone. There's no need to. But in the app that I had where it's monitoring how fast you're moving, it's making that calculation based on the phone. So it only works if the phone is in proximity with a GPS connection. So there are a lot of different options you have right here with this, and there's a big scale of complexity on how far you want to go, whether you want it to be a standalone app, like a scorekeeper app or a calculator, or whether you want it to actually be actively communicating, or the set and forget, like the timer for taking something out of the oven. It's something where you send it, you set it, and you forget it. You're not making that continuous communication. You don't need to sync that timer up with anything else. So one great way to open up a full screen app is through a notification. So when your user gets a notification, like, hey, I noticed you started riding your bike. Swipe to the left, open the full screen app. That's the easiest, most fluid way that the majority of full screen apps are opened. The other way that you can open a full screen app is scrolling down to the settings or open app and then scroll through the list of apps, and it's a real major pain. There are some existing apps out there that have kind of a hacked menu, but I think it's one thing that they either haven't thought through or assumed that users wouldn't necessarily want to do. So you want to think about, if you have a full screen application, think about the context they'd be using it, and try to, in some way, send them a notification suggesting that they might want to be using that app at this point in time. Or have a kind of like the weather app, have a subtle in the background notification that always gets updated that they can go to and open up the full screen application. So there are strategies to doing that, because a user realistically isn't going to sift through a bunch of menus to try to find your app to open it up. And whenever I try to open the compass on the phone, it's a real major pain. Another thing you can do that I honestly have never done is open an app via a voice command. So you could start a run, start a bike ride. And I think that as I maybe start to use the watch more and start to learn that, it will become ingrained in my head. But for now, I just don't do it. And so think about that. Think about users not necessarily being able to even find your app if it's there. How will they know it's there? Again, in many cases, notifications may be enough. So Android Wear and debug mode. Many of you may actually have a physical watch that you want to test with. The great thing about, especially at least on the LG watch, is that you can connect it to the base plate and then plug it in directly via USB and debug via USB directly from the watch. But before you can do that, you've actually got to put it in developer mode or debug mode. And the steps to do that are very complicated. I have the 5 steps here. So you have to tap the home screen twice, bring up the menu, scroll to the bottom, click on settings, scroll to the bottom again. If there's no developer options, tap on about, and then go to the build number and tap on it 7 times. Yes. So before you're going to be able to debug, or even have Android Studio even recognize this physical device, you have to go through all of these steps. Just once on this one though. Unlike the ADB command, you only need to do this the first time, and every other time you plug in your phone, it recognizes it. But I will say that having done a software upgrade, it does need to be done again after you update the software. So keep that in mind. Always check to see if it's there before you pull your hair out because the device isn't showing up in your list of connected devices. And I also find that testing and debugging on the physical device is much easier and much better than using the device manager. So if you actually have a physical device, I would recommend trying to get this set up and connected while we're here, because in the end, it feels a lot more like the app being able to swipe through things. The emulator feels a little bit clunky, and for me has never, it's never been quite enough for me other than just doing quick tests. All right, so now that you've got your Android Wear device in debug mode, you can set it up to debug over Bluetooth or debug over USB, and then it should be recognized. If you do through USB, it should be recognized by the Android Studio. And then the other thing to keep in mind is that when you have it connected to Android Studio, you want to make sure to select which target you want to run. So in this case, I just have the app, because like I said in this example, we don't have a specific watch app. But in the case where you do have a full screen Wear application, you're going to have different runnables. And I found out last night when putting some of this information together, it will let you install your mobile app onto the Wear device. It'll just tell you that the app crashed and that you should fix your code. And I thought for a second, it's like, this is out of the box. I just went through the wizard. There's no way that this app is crashed. There's no way that they made that big of a mistake again, right? Because out of the box, right when you downloaded the Android Studio the first time when they released this, they were using a Wear activity class that had been deprecated, that was in the wizard. And it did crash, it didn't work. So I was like, there's no way they did that again. And it was because I didn't have my Wear runnable selected. So if you do want to debug on your Wear device, make sure you have Wear selected. If you actually have a Wear application, hit run, and then pick your Wear device from the virtual device list or pick your actual watch. I really wish it was smart enough to know, like I picked Wear and then it should only show me Android Wear specific devices, but it's not that smart yet. Hopefully in a future update. Yes?
Please show the configuration, your Wear configuration quick.
Yep, you want to take a look at this guy?
Yeah. It's the same.
Again, this requires, the x86 required the Haxum library that I had to install directly from I believe it was in the extras, Intel hardware, Haxum for Apple. So I had to install that before the x86 emulator would work, or you could use the AMD emulator. But this will make your emulator run 100 times faster. So if you're going to use the emulator, install this. And we'll walk around. We've got a number of breaks where we can help get people set up if anybody's got any additional questions or specific issues. So when you run this, if you're running the Wear example, select Wear, run it, pick a Wear capable device, and when you want to run the complementary mobile application, select mobile and run that as well. And in my case, the easiest way to debug and run Wear applications is to run them on the physical device via USB and then run the application via USB on the phone and select the debug points from there. That was the most reliable and easiest way to actually debug this stuff. The second easiest would be to use a physical device and the AVD emulator virtual machine. So the last example, I didn't commit it to the repository yet because it's really just creating a new project through the wizard and selecting Wear. So when you create a new project, you want to pick whatever minimum version of Android you want to use and then pick the Wear checkbox as well, and it will walk through the wizard, and when you're done it will create a mobile directory and a Wear directory for you. And then here's the code for that example. This presentation is also public. I can share that out as well via the group or on the, when I'm done here, I'll post it to the page so that people can go back through this and look at it and get all those little tips and tricks that I had in there and get links to all the code examples that I've got. And for me, I've come to an end of my time and have additional resources. The Tuts Plus Wear tutorials walk through what we talked about today. So they walk through creating those notifications, creating the full screen notification, really all of the basics. And even though it doesn't sound like as much fun just doing the notifications, it's a great exercise for you to walk through and understand the basics so that you have a good jumping point into how do I get into my full screen app? How do I navigate through these things? The Tuts Plus tutorials are great. I found them to be very easy to use. At this point, they are a little bit dated in the, some of the stuff they say to download. There is a code lab that we're going to suggest you download and run as a part of the code lab we have today. It's a great starting point with a lot of different examples set up in there. There are design mock-ups. I've got a thumb drive as well with a lot of the stuff on it. So I've got the SDK and some other stuff if you don't want to download. It was 4 gigabytes of data for all of the SDK stuff I had, and that's compressed. It was 8 gigabytes uncompressed. But the design mock-ups are great. There are a lot of PSDs for all of the different examples that Google has provided. There's a link on how to set up Bluetooth debugging, which is something you may want to do today. And then the samples from this presentation are on my GitHub. And the blog post that I wrote today, wearable strategy, do you have one yet? And that talks about, what is a wearable strategy? Should you have one? And spoiler alert, yes, you should. You should be aware of wearables, and if you can't convince clients of that, send them to this post or talk through this information saying like, hey, these users are going to start to hate your app. You're going to start to get bad reviews, get ahead of that. Even if it's as simple as just adding another icon or background image to your notification. All right. Well, thank you very much. We'll save questions on my presentation until we get to the code lab. Just with time, we want to make sure everybody has enough time here. So we will reconvene if you have any questions and getting started. Find me or really anyone in this first row here. We'll probably be able to help you with getting started and set up if you have any questions. Thank you.
So I realized I didn't get an overview of the agenda for tonight. So we've got 4 presentations. Mike and Chris. We've got Benjamin and Brian are going to talk again about Android Wear, and then I've got a topic of Polymer, and then we're going to break for food and networking at that point, and then reconvene for Code Labs. We really want to try and lay some groundwork here at the beginning, so we understand what to get into, take a break, and then get our hands on some code. I realize it's a big chunk of time. If you need to take a break, bathrooms are out through those double doors and to the left. There's a cafeteria place right across the way if you need to get something before. It'll probably be about 7, so we've got about an hour and a bit before there'll be food.
Where did you get the white?
The place across the way, she gave me a couple of
Okay, so Chris did a good job of telling us about making some advanced notifications that you could push directly to the watch. And what we're going to do, Benjamin and myself, are talk about going beyond notifications and actually creating apps, creating these full screen apps that you talked about for Android Wear. So I'm going to focus on making custom UI. And then towards the end, Benjamin's going to talk about data syncing. So it's worth emphasizing that Android Wear is Android. So if you already know Android, you already know like 90% of what you need to know to make a full screen Android Wear app. But as Mike said in his talk, you suck at your job, because just because you can do some of these things doesn't mean you should. You really need to tailor your skills to this new sort of form factor. Because there's a couple things that are really obvious, but you need to take into account when you're building an Android Wear app. The first is that they can be square or round. That's kind of a big deal when it comes to making layouts. And they're also small. So because they can be square or round, you have to make sure that your layouts are shape aware, because something that looks good on a square watch might not look good on a round one. And because the watches are small, you shouldn't try to cram in too much into one screen. I think both Mike and Chris kind of covered this. So you want low information density on each of your screens, and you want to use big gestures to kind of get around and do stuff. So what Google has done is they've created a wearable support library with a bunch of new tools that you can use and include to help make your UI work better for a wearable. All you have to do is include a couple lines in your Gradle file and you're all set. And you get a bunch of new classes that you can use. So I'm going to be going through a bunch of these and telling you how and when you should use these. So let's start with shape-aware layouts. So let's say we start with a normal layout. Let's just start with a normal frame layout. Put views in the corner. That's going to look just fine on the square watch. But if you come over to the round watch, it's getting clipped in the corners. It's not going to work. You can try to fix that by adding extra padding, but then that's just going to cram things in on the square watch for no reason, just to fix the round one. So that's not what you want to do. So we have a new tool, box inset layout. What this does, you can take your original layout, and you can wrap it in this new thing, box inset layout. And you have this one new attribute here called layout box. And what layout box does is it will add extra padding on just the round devices. So at runtime, this layout is going to check to see what kind of device you're using. If it's a round one, it's going to pad it, and it's going to leave the square one alone. And you have some freedom with how you do this, because maybe you don't always want to pad it all the way around. So in this case, I've picked all, and it's padding all the edges, but you can pick some combination of left, right, top, bottom, and all. So it kind of gives you an idea of how this works. Maybe you just want to pad the top or the sides, or you can do the whole thing. There's another way to do this, which also gets around this square round problem, and it's called watch view stub. So what this is, it's pretty much an empty layout that points to two other layouts. One of them is a round layout and one of them is a square one. And at that point, they can be completely different. So here I specified a square sort of base design for my square watch and a round one for a round watch. At that point, you can do whatever you want. So the two layouts that are in here, just standard layouts that I just made sure look good on either device. So the one catch here, when you go to use this in your activity, because it's doing a runtime check to see what the device is, it takes a little bit before the actual layouts will be inflated. So if you need to get reference to your views, if you do something with them, you have to wait. So you have to set this listener here, this layout on layout inflated listener, and wait until it's ready. When the layout's done, then you can retrieve your views. All right, so between a combination of box inset layout and watch view stub, these end up being the root of most layouts when you're doing an Android Wear app. So for pretty much everything else I'm going to show, I'm going to be using box inset on every layout, just to provide the padding I need for the round watches. All right, so let's talk about cards. If you've used an Android Wear device at all, you know that cards are everywhere. It's a very familiar part of the design language. And with the support libraries, you're given a few tools to make cards of your own. And you can see there's kind of two different types here. The ones on the left, the ones on the right. The ones on the left are very easy to set up. They have a fixed format. So you have a title, you have some content, and an icon. The one on the right takes a little bit more effort to set up, but then you can do whatever you want within that card. So the first type is called card fragment. And I've just shown here that you can literally set this up pretty much in one line. And you can add this second line where you can tell it, if my card is small, do I pin to the top or the bottom of the screen? And that's it. Then you just add that fragment the way you normally add a fragment to your activity, and you're all set. You have your card. The other type is called card frame. There's a few more steps here. So you're going to have your layout. You're going to have your root layout, which is usually, like I said, a box and set layout. You're going to put this inside something called a card scroll view. It's just a container that you're supposed to put a card frame in. Put your card frame there. Then inside that, you can put whatever you want. So this is sort of an example here. We have box and set layout, card scroll view, card frame. And then you can add one child, and then within that child, it can be whatever layout you want to do. And so here I've just chosen a few text views, moved them around a bit, just as an example. So in your activity, there's also some things that you can do to configure this. Just like your card fragment had this gravity that you can set, tell it pin to the bottom or pin to the top. You can set that on that card scroll view container to do the same thing. All right, so now let's talk about lists, because these are interesting on Android Wear. All right, so this is the sort of, when you go to the settings in Android Wear, this is kind of what you see. So as you're scrolling, you get this kind of snapping behavior. You also get this sort of expansion going on. But it's all based on the idea that there should really just be one big clickable thing at a time. And if you can try to click on the top or bottom of any one item, it's just going to scroll to that position. So the support libraries include wearable list view. So here's my example where I've used wearable list view. You can do all the same stuff. So it's really nice. All right, so to implement this, there's three pieces. You have your wearable list view, which you'll put in the layout. You'll have your adapter, which you implement to add the data and populate your views. And then if you want, you can implement this wearable list view item interface. So in terms of the layout, just add it the way you would normally add any list view or recycler view. The adapter interface is pretty simple. You have your uncreate view holder, where you initially create a view holder. Find view holder, where you take a recycled view holder, populate it with data, and then data item count. So if you've ever used the new recycler view class, that's pretty much all this is. And if you want, you can create your own custom view holder class to hold your views. And then setting up the adapter, this is all you need to do to get the snapping behavior and all that stuff. So really just, you get a lot right out of the box using wearable list view. The fun kind of comes in when you implement this wearable list view item. So this is something that you're going to put on a custom view, and that's going to be what you use as the main views of your adapter. So the interface here, you sort of set up an initial range of values that you're going to animate over. You have these two methods to get and set the current value. And then you have initial and final sort of startup methods. So I'll show you how this works in a moment here. All right, so you would take this interface, just make some custom view class. It can be whatever kind of layout class you want it to be. And you just inflate this in your adapter. All right, so here's an example of what I used for the animation that I showed before. So I'm going to have a scaling factor that goes from just 1 to 1.5. In this get current proximity value, I'm just going to spit back the value that I'm given in set scaling animator value. And then in there, I'm going to animate my circle to be larger or smaller. And I'm going to change the alpha value of the text in the list. And for these final two methods, I set it up so when the item is active, give it a blue color. When it's inactive, give it a green one. So here's that list again with all those features. All right, another fun pattern is the 2D picker pattern. So if you have a Android Wear watch, or if you've ever set one up, this might be familiar. This is just the initial setup where you kind of get an idea of how you navigate the system. So what's going on here is you have a vertical list of main items, and then you swipe right to drill down to more details. And so they're calling that the 2D picker pattern. So we have a class in the support library that can do all this. It's called the Grid View Pager. So here's my implementation. So I'm taking Guardians of the Galaxy characters and showing sort of quotes. So you can see here that we had our initial list that we went through our main items. We drill down into the quotes. We drill over again, the quotes there. All the good group quotes. All right, so another fun thing that's going on here is you can see these parallax effects happening, which is something that happens a lot in the system. And also crossfade as you go between these main items. All right, so how do we do this? Just like before, we just take this, just put it in our lap, pretty simple. And we have two choices of adapters that we can use, and this is very simple to a normal view pager. You can either use the grid pager adapter, which works with views as the main items, or fragment grid page adapter, which uses fragments. And again, the interface isn't that complicated, and it's not that much different from a view pager adapter. The only difference is that now instead of just having a row, you have a row and a column. So you have to set your data up in a way to be able to handle that. And then instead of just a count, you have a row count and you have a column count. Something you can optionally do is specify a background for your row or column. I recommend that. It's a really fun feature, and it's not very complicated. So in my case, I just have an image resource associated with each row of my data. And you just create one of these image references really quickly like this.
All that parallax stuff is integrated in that.
It's all baked in. So all you have to do is implement this one method, and you get all of that crossfade and parallax for free. It's really nice. All right, so now let's talk about delayed confirmations. Okay, let's say you're an important person and you're scrolling through your watch. You happen upon this tempting button, but you want to get rid of it. You want to dismiss it, but you have fat fingers. So you accidentally hit the button. That can be problematic. You just did something, very big accidentally. So here's where delayed confirmation really comes in. So what this does is, instead of just immediately doing the action, you pull up this new button with sort of a countdown timer around it. So it gives you a little bit of time to click on the button and say, I didn't mean to do that. So this is what it looks like in action. So we're going to scroll over, get that, hit it, just cancels it. And in case you actually meant to do it, you let the timer go down, and then it completes whatever the action was that you set up to do.
Can you show us the code for launching goose?
So the delayed confirmation view, you just add it like any other button. But one thing I wanted to show, I don't know if it's easy to see or not, but there's a lot of attributes that you can set on this because it's very configurable. Besides the size, you can set the color of the countdown timer around it, the width of that, what icon appears there. So there's just a lot of stuff that you can do to customize it. So once you have it in your layout, there's only a couple extra things you need to do in your activity. So you set the time that you want it to take. You set a listener for the cancel and finish events, and then you start it. That's all you have to do. Just wanted to show you what the listener looks like. It's just on timer finished and on timer selected. and you can choose to do whatever you want to do in there. So as an example, this is what I've done in my case. So on selected, so when you click it, just marking it as canceled, and then showing this toast message that it's been canceled and finishing the activity. When it's confirmed, first I'm checking to see if it's canceled. Don't do anything if it is. Otherwise, I'm just launching this intent for this confirmation activity. So this is another piece of the support library where you can get that sort of, confirmed information that the system uses just by launching an intent with this activity. Okay, now let's talk about long press to dismiss. Okay, so swiping to get rid of stuff is the default for the system. So I have my demo activity here, where each of these items just fires off another activity. And just by default, you can swipe those to get rid of them. But some apps might need to disable that. Maybe, swiping left and right is part of what your actual interface is, so you can't have that get rid of your activity. So what you can do is in the theme, you can just say swipe to dismiss is false, and that'll completely disable that. But then you are required by the design guidelines to implement the long press to dismiss pattern. There's nothing they can do to force you to do it, but you're supposed to do it. And so the way you're supposed to do it is by including this dismiss overlay view. And basically this is just to do that if you long press, it'll just pop up this big red button here. If you click that, it cancels your activity. And all you have to do is just make sure that you place this in some kind of layout where it'll sit on top of all your other content and sort of, expand in all directions to fit. But just adding in the layout isn't enough. You actually have to implement all the, dismissing logic and gesture detection yourself here. But it's not that much. So you just define this gesture detector, and you just say that, when you actually detect a long press, show this overlay view. And then once it's shown, you can decide what to do. And then once you have the gesture detector, you just set your activity up so that it's intercepting events, looking for this long press and making sure that long press event gets fired. So this is just what it looks like here. Okay, so I've gone through custom UI. Everything that I've done for those examples uses local resources, but there's some limitations about using, making a full screen wearable app. And Benjamin's sort of going to discuss those and talk about how data syncing comes into play.
In order to synchronize data, we use a class or an interface called the data item interface, and this facilitates synchronization of data. It has a restriction of a max of about 100 kilobytes of information, and it requires you to have a unique path to identify the data on the system. However, you're usually going to be using the data map, which is a kind of a wrapper around the data item and allows you to interact with the data like you would a bundle. And then Android handles serialization and deserialization. The requests are sent to the device using the Google Play SDK API. And this is done with the request mechanism. And here are the two classes that are used for that. And the request, the data map request is the one you're generally going to be using. This is an example then of how to connect to the wearable data layer. The important piece here is to notice the add API where it says the wearable API, and then to make sure you then call connect on the client. Sometimes you will get an exception if the user doesn't have the Android Wear app installed on the phone. If you try to build this API or if you try to connect to the client and you've added the wearable API and the Android Wear app isn't on the phone, it'll throw an exception. In that case, you want to have two instances of the client in your app and just check that exception and build a different instance of the client. This is an example of how to send the data. Really straightforward. As you can see, you get an instance of the map, and you add the string that you're going to send to the device, and you just push it through to the client. In order to listen for events, you can use a wearable listener service, and this is registered in the manifest like any other service, and the activity or the service will be started by the system when an event comes through. Otherwise, if you only need to listen for that data at a certain time, you can set up the activity to be the listener. The wearable listener service is provided with the or the wearable SDK, and you subclass it and you override the on-data change method, and then in the manifest register this intent filter. In a listener activity, you'd want to implement those three interfaces, and then when the connection to the API client is successful, you then want to add the activity as a listener, like that, and then override again the on-data changed event handler there. Sometimes you want to send larger files to the wearable device, and Android lets you do that through what's called asset, and this will let you send like an image or sound file or something bigger than 100K max. However, it can be really slow over the Bluetooth connection and takes up a lot of space. So you want to be judicious about how you use it, and careful you're not sending more information you need. So often, if you're having a handset application, go out to the internet and get the image. You want to scale that down to the size that you need for the wearable before you send it over, instead of doing that conversion on the wearable side. And that's really straightforward again. You just use the data request and you put the asset right in there like that, or the data map and use the same method there. Android also, or the Wear SDK also has the Messages API, and this is more for remote procedure calls or call and response messaging types. It doesn't do any syncing. It's just one-way communication. And it's, again, very, very simple API, just one method call there. And to receive, you just override the on message is received, and this is either in the wearable listener service, or if you implement that in an activity. And that's what we've got. And all the code that we've written to go along with these demos is available in that GitHub repository there. Any questions? Sweet.
All right. Right on time. This is pretty cool. All right. So we're going to shift gears now. It's a lot of Android Wear, some pretty cool stuff. I think the code labs will be great. We're going to shift gears into not Android talk, into Polymer, which is more specifically for web applications. And I'm going to bumble through, actually unmirroring. All right. Cancel that. Start with speaker notes. And what do you do? Screen. All right. should have asked if anybody needed a break. It'll be good. If you need to get up, I won't be too terribly offended. So, I'm Lloyd Cleveland. I'm one of the managers, or co-organizers of the Google Developer Group Twin Cities. I also work here at McAllister College in advancement and fundraising, and write a lot of custom web apps for that team, whatever. I've really been enjoying getting into Polymer and learning about what tools and power this provides for people who are building web applications. So today I'm going to go do an overview, talk a little bit about web components, and kind of invite you all to join this revolution that's happening. This visible to me. So we're going to start with some high-level review of what are web components. Get up so that we're all on the same page. And a good way of thinking about any kind of new technology. There's a lot of new technology that happens a lot. One way to think about it is, what problems are we solving? What are the issues that are happening that this uniquely provides an answer to? And so, how are web components going to make it easier for us to do our job? Well, web applications are really becoming that. They're really expected to be a full-fledged application, and they're not necessarily landing on any standard device. The days of designing a website for 800 by 600 screen are kind of out the window. You need to be able to easily adapt your application to a myriad of device sizes. And we're all smart developers. We do a good job at this, but it's work. So to give an example, something like UI, doing some UI tabs should be pretty easy. I mean, this is 2014 already. But it's kind of a pain in the butt. Right now, so here's an example of how many of us doing a web app these days. Here's an example of kind of Bootstrap or Foundation. Some libraries do a mix of HTML and JavaScript. Some try and do as much as they can within JavaScript. And we're all super smart, right? And after a few times of doing this, it's not so big a deal, but it's still really repetitive in the wrong places, and unnecessarily so. And they're all solving the same problem, but they're all doing it in a different way, which makes us developers have to constantly learn new frameworks, and most frustratingly, they're often not compatible. So loading a Bootstrap with a framework, or Angular and Backbone, and you start to get collisions with the framework that you're building. So this really is where web components show their true power. So with web components, we can create our own custom HTML elements. You can create paper tabs, have its own look and feel and behavior, and they're built on the web platform. Can be used in any project, reused in other projects, extended within that project, in true kind of developer, what we would expect from a real developer tool. So how's this possible? How did we get to this point? A number of engineers from different web browser companies, so Google, Firefox, Opera, Internet Explorer got together and started to agree on a new spec, looking at common problems that web developers were facing, needing things like templating, scoping of your definitions, encapsulation, resource management. And these web components really are a quantum leap in web development. But I do want to quickly differentiate between web components and Polymer. So are kind of talking about it in the same conversation, and I do want to draw a clean line between web components, which often come up in the same conversation as Polymer, because Polymer is built on web components. And Google, the perception may be that Google kind of owns or is in charge of web components, which isn't true. Web components are part of the HTML5 spec. They're open standards. You can implement web components with Google tools or without. I'll get into some details of that just a little bit later. And the HTML5 spec and CSS3 are owned by the W3C. a consortium of developers across all browsers and kind of leading the edge of web development. So web components really break down, the thing that defines a web component are 4 key elements. The ability to create custom elements, have HTML templates, the shadow DOM, which is about the coolest thing ever, and HTML imports. So custom elements allow us to define new HTML elements. And the problem that this solves is this. This is a modern web application that many of us use on a day-to-day basis. This is kind of behind the scenes. You open your dev tools in Gmail, and in order to not have conflicting div CSS definitions, you've got this crazy soup that's well, it's clearly not readable, and obviously maintainable, but it takes some serious doing. Basically, HTML has not kept up. So web components allow us to turn our divs into components that look like other HTML elements, which makes it very readable, meaningful, because you can read this code, tell what's going on. We're leveraging the web platform, and you have a common extension model, so you can build upon elements that you've built in other projects or other people may have built and published, and you can extend upon those. Since you already know how to work with HTML and the DOM, you already know how to work with these custom elements. There's a common way to extend and work with those. So one of the other attributes or elements that comes up are templating. You have real templating in the browser. So most of us building web applications are fairly familiar with, pretty standard. You have to build a template in your server-side application. The web components allow you to build your templates on the client side. So spec writers saw that everybody needed these templates and said, hey, why don't we make this part of the web platform? You've got a template tag, which is now, the template tag is a web component tag. The content is inert until cloned or used. It's meaning it kind of sits on the page and doesn't actually do anything until it's instantiated on the page. And it's not part of the page. So one of the other real powers that come with these web components is the idea of a shadow DOM. So imagine a bubble of CSS or markup that's scoped. So your CSS styles don't affect the parent document. External JavaScript can't mess with elements within your component. One of the examples that they give in the Polymer project is setting up a simple Polymer element and redefining the CSS of, say, H2 as orange. Well, just within your web component, that item, which is H2, which is a pretty commonly used tag, is orange, but nothing else on the page is affected. It allows you to really define and kind of work with basic markup tags and not worry about site.css or style, other style definitions changing how you intend your element to look. Of course, there's a workaround for that because there needs to be. One of the beauties of the shadow DOM is you've actually been using it for years. So a common markup is this video with the source and enabling this controls attribute. You now have a play button, a mute, you've got all these controls that are embedded in your video. Well, this is, it's like it's magic, right? But it's actually the shadow DOM. You could open the dev tools, enable show your UA elements, the shadow DOM, and inside that tag, inside the shadow root, you've got the markup that's used with the standard video controller. So browser makers have they kind of been holding out on us. And this allows us to roll it in. So HTML imports allows you to import HTML documents into your application. This looks a lot like the server-side imports that we're used to doing if you have access to server. And the nice thing about it is it fundamentally changes the way that we're able to work with these libraries. Here's an example for Bootstrap. To even get your hero element up on a basic page, you have to import about 6 lines, 6 different files, your JavaScript and CSS and some different elements. That's a lot of stuff to include. Using HTML imports, that's broken down to just 1 line. Now, many of you may be thinking, I might have heard this story before. So here's an example of one of the sample Polymer tutorials where each of the custom elements that you're bringing in, you need to individually call. Oh, funny, I put my, anyway. So it does cause its own problem. Hopefully okay, so, sorry, I broke my rhythm. But, so there's elements of Polymer. So this is stepping outside a little bit of web components, and I call these Polymer pixie dust, which is not the official term, where you've got this tool called Vulcanize. And so by running from the command line to vulcanize one of your files, what it does is it imports, it looks through your HTML file and checks for any imports that might be called. And then rather than loading, having a browser, which most of course, you know, our home base is our desktop with our 27-inch screen, right, on a super fast connection. You don't care if the New York Times takes 320 unique web calls. But on a mobile device, that matters. Each one of those HTTP requests are expensive. This Vulcanize command will look through all of your file and import all of them and flatten them into one file, or even inline them all into a single file. It makes for a much longer single file, but it reduces the HTTP imports. You can also incorporate Vulcanize into your build process. There's Grunt Vulcanize or Gulp Vulcanize. So web components, 4 key parts. There's the custom elements, templates, the shadow DOM, and HTML imports. So to use this, how to use it, you can find them. There's a number of different repositories. A site like customelements.io. You can use a package manager like Bower to download and install, which will go check for any dependencies and bring them into your application. And then you just import them up in the head of your document. Import the resources you need, and the library handles the loading of any resources that are needed, and they're ready to use. So you can compose elements together. Here are a couple nested elements, which will result in a toolbar with some text in the middle that's nicely centered. It's got a couple of core icons. This is from the core icon set. You've got your hamburger menu, some refresh, different actions that you can tie into them. I like to point out for Polymer, there's kind of 2 key reasons why using Polymer, in addition to web components. There's many more reasons why Polymer is pretty great, but for now I really want to highlight 2. There's polyfills and simply the library of elements that come with using Polymer. So polyfills are answer this question of what is the browser support. So web components, in the summer of 2014, if you did a survey of all of the standard major web browsers that exist, they're supported pretty well across most of the 4 key requirements that we talked about for web components are met across the different browsers, which is a lot better than it was even less than a year ago. By bringing in Polymer and polyfills, which comes when one of the initial imports we bring are web components. So there's a JavaScript file which will check a number of things. It adds a bunch of syntactic sugar with Polymer.js that is in part of the web components. So this browser support of web components now goes from partial support in some browsers to full support across all modern browsers. And now that we have full support for web components, we can explore what we get from these different technologies. So the first one being custom elements. We'll kind of walk through some code of first showing how to create custom elements in vanilla JS, and then Polymer, and how to use it. So the way you use a vanilla element is just you register the element on your document.register element, you give it a name, a prototype. And in Polymer, they've said that, hey, kind of declarative is the way to go. So you create a custom element that allows you to create custom elements on top of that. This Polymer element is the root element name. And then using the Polymer element tag, you give it a name, and the content inside is rendered. So you would use that on your page by referring the tag based on the name that it is. So also talked about extending elements and the power of that. Say you want to create a button that's not just a button, it's a super button. In vanilla.js, you would pass the tag name, a prototype of the thing you want to extend from, and pass in the HTML tag name you're extending. In Polymer, it's pretty well slimmed down. You just pass in the tag name, and they'll sort out the prototype. And to use this new type extension element, we'll say the button is a super button, and you can extend native HTML or other people's custom elements. So one of the other kind of syntactic sugaring are of course, the templates. Using templates is super easy. In vanilla, you just use the template tag, declare some of its the pieces that are used within it with JavaScript. In Polymer, there's a base structure for each element. And so every element, by default, will have a template, or by definition, will have a template. So the content you place in your template is what will appear on the screen when it's used. In addition, there's a number of kind of hooks that are now available to you. Like you can bind to data models, you can iterate, there's conditionals available to you. It really makes some pretty powerful pieces to put in. So the shadow DOM is really powerful, but there's ways that working with it, there's some tricks that may come up. So here's in vanilla.js, you select an element, call create shadow root, and fill it with the HTML, either with inner HTML or a template. In Polymer, the definition is anytime you have a template in your element, it by default will have its own shadow DOM wrapped around that element. So, components. In traditional app development, we're used to using standard markup tags and working within a site CSS at the site level, or maybe the page level has its own kind of overrides of the site CSS that you try and make a consistent look and feel across all the different pages. And they're fairly generic. So, but what if your HTML could look more declarative as to what actually is happening? With mark components, they have their own contained markup, or inherit the markup from globally declared design. So that's really kind of covering the polyfills, that using the Polymer library, one makes it fully functional on all modern browsers and extends all of these elements available to you. So the other, I think, big win with using Polymer is this library of elements that has already been created. I was just at a conference where Mike spoke last week on all about mobile technology and mobile, the thought leaders, and if I see another one of these graphs about how mobile traffic is overtaking desktop, I might scream, so thank you for not including one of those. I obligatorily did a bunch. But so knowing what we know now about mobile devices, what if we started over? We could work with elements that have a look and feel like the kind of elements we're used to seeing on iOS or Android. And these are all part of the core element set that come with Polymer. We've got a core icon with a search, a field, a paper button there, this core drawer panel, which will extend out the side content on a larger screen and hide it on a smaller screen. So core elements are from the Polymer library, a set of general purpose, general utility elements. So one of the things is this basic container for tabs or buttons of core toolbar. Like any custom element, first you import the definition, and then you just work with the tag. In this example, we've nested a div. I think this has a pointer in it. There's a div here in the middle of core toolbar, and the template then wraps this display out appropriately. Because custom elements are really all about composability, you can nest additional items in, like another core icon button to get your hamburger menu next to your div. So a common pattern is to nest a core toolbar in another element called this core header panel. And the core header panel is a simple container with this header section on top. And it's a good place to nest a toolbar in the content section below here. And the headers panel is to manage the scrolling of our page. By default, it'll pin the toolbar to the top. And at this point, we've written about 8 lines of code and gotten all of this element. In this example, there's a bunch of filler divs, but you understand that's within the content there. Pretty nice experience. On a larger screen that you can change the look and feel or height of that header panel based again on the conditionals that are available. And we're not writing a bunch of JavaScript or CSS or importing that into every single page that we want to have something like this happening. Because these elements are configurable, we can change the mode of the panel. So by adding mode equals scroll to this, the toolbar disappears when you scroll up the page. And there's other kind of core tools within this core set that allow for a nice responsive design that effortlessly look good on a desktop or on a that have this side drawer panel and the content. And by default, it'll only display the main area on smaller screens. You can combine all of these, the toolbar, the header panel, and the drawer panel. And with those 3 elements combined, we've got now a pretty sophisticated experience. So Google I/O, this last summer, they announced Paper Elements, which is the new kind of UI, the best thinking of the user experience team at Google on how things should look in mobile and on the web with these paper elements. So with core Polymer, there's a whole suite of tools that wrap these core actions with the paper UI. They're more stylized, and they enable animation and spatial relationships. So this paper input tag has a few interesting attributes like this floating label, data validation, the error label, and all of this without a bunch of JavaScript and CSS again. And that means they've taken things like your standard text box and modernized it for 2014. This is the element called paper checkbox. Has a touch action, a paper ripple happening when you touch, the transition, more of a fluid look and feel to the application. Paper ripple is where you click or touch on an element. It gives this more active feel to your application. And this is a simple drop-in to get your elements. You just put your paper ripple tag here inside of a div, add this fit to it, and it will expand the paper ripple all the way out to the edges of that containing element. Not a bad effect for a single line and 20 characters. So the other elements of paper that are fairly iconic is the idea of this paper shadow and the Z depth, that elements should have layers to them. You should have a sense of what elements are on top of other ones on the page. It makes your elements kind of spring to life and have a nicer feel and reaction to them. So, styling. We've talked a little bit about material design. Let's talk briefly about theming and how do you make these elements look like they belong on your site across a bunch of different elements. So, taking a pseudo element like this paper slider with a min and max, it's got its own contained shadow DOM. To style that in your CSS markup, you need to say within that shadow element and change the style. You can also pierce all shadow DOMs on your page with this deep tag. And allows you to do something like setting the background color for all paper elements as, say, this green. So there's a link, I think it's pretty small on this screen. It has a kind of a playground of all of the different paper elements that are available to you in the Polymer suite. One of the flagship Polymer app is this app called Topeka, and it rolls together a bunch of different experiences that you can make pretty simply, combining different Polymer and paper elements. It has animations. Here we go. Animations created with the core animations. You can do really powerful stuff with it. It's a little quiz app that will walk you through a standard set of questions, collect your results, and you can play within different subject topics. So, in tonight's talk, we don't really have time to touch on all of the elements. The Polymer project lives at polymer-project.org. And there you can find examples of all of the different core elements and paper elements and tutorials from that page that are pretty nice to work with. So one of the things of Google building their library of web components, they're not alone. Mozilla is building their kind of experience set, an element set called Brick. It's designed with the Firefox OS in mind, and it has a standard similar look and feel. They're named just a little differently. And Brick uses the polyfills from the Polymer project, which means that you can use Polymer, Brick, vanilla web components together in the same application and not worry about stepping on each other's toes or breaking something deep in your site. So one of the things about web components that really extends even to makes it more powerful is it's not just the browser makers that are making this. There's tons of developers that are building custom elements and publishing them on GitHub or customelements.io. So here's some examples. There's this element of App Router. Eric Ringsmith has this element which allows the page to manage basically handling routing requests within the hash change in the browser address bar. Combining the change of that and HTML5 push state. So Adi Asami has built this pager element which allows you to add some pretty nice paging elements to your application. There's Ajax forms that will allow post-back and validation by just adding this element to your page, including full-blown web apps running currently on Polymer. The entire Polymer project is built using Polymer elements. The ChromeStatus.com, Chromium dashboard, is heavily using web components and Polymer elements. There's, I should put this at the end, but this is a pretty cool tool to use on building web components, Polymer web components, within a tool that is itself a Polymer web component. If I have time, near the end, I might walk through a demo of doing that. GitHub is using for the timestamp is a web component for the X minutes ago widget. And not just Google. The folks at Salesforce have started turning their APIs into elements and web components. Which brings us to these APIs. As web developers, we spend a lot of time working with APIs to exchange data, consume data, publish data. And APIs as elements. Again, a lot of the work that we're used to doing as web developers is, you've built something like a Google map 4 or 5 times, it's fine, you understand, you import, well, here's my example, you want to add a marker to Google Map. There's so much code for just to get one marker to show up on your page. Well, in the world of web components, this is just a single tag. In the body, of course, up top, we've imported the element. So you import the element, you put it on your page, and you've got a map now inside your application. You don't have to know how to style with CSS. Use a container to load the library. You just include it on your page, and you're done. And you pass in variables. Since maps, anybody who's worked with Google Maps knows it's a really rich API. It has lots of things that are valuable to us, like centering the map using latitude and longitude, setting the zoom level, adding pins. In web components, you can expose the functionality of your API through attributes of your component, and it will recenter them and reset the zoom level. So and including something like a map marker is as easy as nesting a Google Map marker with its own elements into the page. There, I should make a note if I can have time to show other proof of concept. All right. So the team at Google, the web component team, has been going around to all the different product teams and working with them to try and publish as many of their APIs. There's over 250 Google APIs that you have available to you as a developer. And they've published them all on GitHub in this Google Web Components repository. So things like working with maps, spreadsheets, calendars, Street View. There's one example that I was just toying with of Google Sign-In. Google Sign-In with a single line of code. It's pretty powerful stuff. One of the other, I think, side benefits, and I don't know how to quantify this, but the Polymer team, I've really been struck by the level of intentionality and education that they've committed to. There's a series of Google Web YouTube channels that talk about getting you up to speed with Polymer and web components. The whole polymerproject.org is well laid out, I think, with the heart of a teacher. I'll point out Rob Dodson here in a little bit. So learning web components, webcomponents.org. It's a great repository, lots of communication, lots of kind of discussion about where these should be, where it should be headed with this. I will add that web components are not, they're not fully official, as we talked about, as for the web specs, since not all browsers support them. The Polymer project itself is still in what's technically a developer beta. The current version they just released this week again, as they tend to do right before a big demo day. Updated all the versions to 0.5. Most of the functionality is still there, all the tutorials are still gonna work great, but it's still being shaped. And so what that means is your voice is important, and things you would like to see included, or ideas you have, there's a lot of fairly open ears within the project. So the polymerproject.org has a great getting started tutorial. Well, this is, anyway, so Polycast is one of the shows on YouTube hosted by Rob Dodson. Rob Dodson is a member of the web standards team at Google, and he really has been kind of the front face in a lot of ways of the Polymer project. These are great. These are all about 8 or 12 minute long tutorials covering a simple element like custom icon set. And he'll walk through in a nice manner and get you up to speed on how you would make your own custom icons or modify the core icon set. So, but you gotta build stuff. You have to get your hands dirty. If you want to make a Polymer application, Yeoman has a great kind of seed app, which adds support for SAS and page speed insights and some other things. If you're not into Yeoman, there's a seed element out in Polymer Labs for you to start building your own custom application, which is out. So Andy Osami also put together one of these DevBite YouTube videos on that walks you through creating your own custom element. So first you create your element and share it. That's really where we're going to get the most power from this. Oops, I dropped a couple slides. Or maybe they're coming up. Anyway, for the code labs today, I might be bouncing around here a little bit. One of the other code projects is there's a Chrome extension, which is, technically it's a Chrome app. So in the Chrome App Store, there's the Chrome Dev Editor. So you'll be able to build, run, debug your own Polymer project and web application from within Chrome itself, which will save a little bit of time of setting up Node or a local server, uploading, those sorts of things. It also does a lot of the package management for you. Getting back to share, you need to share the things that you're building. So there's a Node extension for custom elements within your Bower definition. If you add web components to the keywords and push it out to be published within Bower, then it will be picked up within customelements.io and show up in the catalog of elements. So then we need to explore. Approach this with an open mind. We've got some hard problems. And it's kind of up to us to figure out the best way to solve these. So we've got a little bit of time. I want to say thank you, first of all. These slides are posted I just posted them to my Google Plus page. So google.com/Lloyd Clegman is where these slides are that have links to lots of those resources. We have a couple. Let's see if we have. This is about breaking things. All right, so we're back here. I am going to hold you captive as we do Polymer project. Polymer project. Tools designer. So here's this designer tool. You've got this kind of open space and then a palette from which to choose from. One of the core components is our drawer panel. So we're just going to drop that over here. Resize that to fit. Oh, this doesn't look so great. Whoops. How do I make that hide? Click that. Anyway, so here's our drawer panel. One of the other components we could add on here is, say, a Google Map. All right, we'll resize that to fit this space. And take a look here. All right, so by default, it's centered on San Francisco because some people like to think that's the center of where things are. I had my notes, I can never remember. All right, so, 9, I always get that wrong, 93914 is our latitude. We're roughly, I mean, if you're playing with maps, it's kind of cool because we're about 45 and minus 93. But if you really want to get specific, it's minus 93.1685. And we'll set that zoom level to, say, 15. All right, so here we are, zoomed in on McAllister College. We've got a map that's built. We've got this drawer panel, which starts to show off its beauty when we resize the page. This drawer panel will hide itself. And if we look at the code behind, we've just built an app with a side drawer panel that's responsive in size, and we've got 10 lines of code here. Recentering the map, setting the zoom level. In order to add a pin, you would drop that inside this Google Map tag. That's pretty cool. Now, they do hide a little bit of CSS in here, but I can't blame them for that. So, all right, we're going to leave that page. See if it's up. All right. I'm going to go out on a limb here and assume that a competitor's cloud service is up and running. Oh, I don't have it always on. We'll see if this loads. So, anybody in college right now? A couple of folks. So there's a service currently, Yik Yak, which is fairly popular. It's an anonymous kind of geographically based chatting tool, and it's on the radar of school administrators, and there's concerns about whether or not, social technology is always scary to administrators, right? So I went out on GitHub and found an API for interacting with Yik Yak, centered on McAllister College. Just went ahead and found the 100 latest Yik Yaks. This is always dangerous. I'm not even going to click on one because I'm live in front of an audience. So if you click on them, you can see. So we're going to go ahead and look at the code behind. So here's the amount of code that's needed to get that page up and running. All right, the imports that are needed that are running this entire application. I'm centering my Google Map on this spot. Uh-oh. I'll make it really big so you only get to see the first one. All right, and then so you can add a marker here at the bottom. There's your first marker. And all my app is doing basically is hitting the API, pulling in the first 100, and looping over them, and dropping them as pins on the page. They're showing up centered. You click on them, they show the text that's available to you. And this honestly was about less than 15 minutes of work on one of my lunch periods. So I thought that was a pretty great, if maybe not appropriate for public speaking, proof of concept. And thankfully, of course, most McAllister yaks are very healthy and thoughtful. So that's what I had to talk about for Polymer. The agenda we've got kind of nowish. We're freakishly like right on time. The plan right now is that the food is set up out in the outer room. We'll have some food. We'll have some networking. We've got this room. There's 2 conference rooms on the second floor that are maybe easier to sit around and do some actual code lab time. These front rows have what are they called, tables that flip up, so that might be more convenient. So maybe we'll play it by ear. I thought there's 70 people registered, 75 people registered for this event. And it's true to hosting an event, almost exactly half showed up, which is still pretty good on a Wednesday at 4. So we're going to do that until about 9, then we'll reconvene in this room. Prior to 9, I'll walk around and make sure that everybody gets the final survey. By filling out the final survey, we'll get you a raffle ticket to be eligible for one of these cool devices. And also, when you fill out the survey, there's a link to get a free O'Reilly ebook as part of that. So that's our incentive to get you to fill out the survey. So we have some metrics. And what I should do is take the cue from our Deb Rao guy at Google, who always does this, to prove to Google that we have lots of people here. Can everybody wave and say how much fun you're having at these events? All right. See, now they'll maybe support us with more than a thumbs up. Any questions about Polymer? I know I'm in the way between you and foods.
Yes.
All right. Oh, yeah.
Any plans on getting to a 1.0?
Oh, yeah. They're rapidly developing towards that.
But do you know what 1.0 looks like?
What the product will look like, or what the timeline looks like?
What Polymer will look like once it reaches 1.0?
My sense is that it's pretty well on the direction it's heading. In the last version they changed some how you reference the core libraries, and it didn't change the functionality of it. It just changed the naming structure of it because it was a little confusing to people getting new to it. I think they're really underway to refine the process of that. What do you imagine it would look like?
Well, we've got a lot of examples of different components that they're implementing from a UI perspective. They said that Polymer is a lot like a framework that you're not only supposed to do visual elements, but background elements, but how far does that go? You know, what kind of services can we expect to implement Polymer? All of them?
I would expect all of them. Yeah, there was just a discussion on the Polymer discussion board about Firebase. So Google acquired Firebase, which is the kind of lightweight front-end database API.
We expect parity between Polymer and Android components. Anything an Android component can do, Polymer can do? Question mark?
Question mark. Well, I mean, that's kind of the debate of native versus web. There's a lot that you can do in the web experience. There's a line that gets crossed as far as the experience that you're able to reproduce in a web application. I think that there's a lot of parallel efforts happening with the paper layout. A lot of that new Android UI experience is looking pretty similar to that. So they're trying to have that be a consistent experience. But I don't know that I would say Polymer is necessarily going to impact Android as a development environment.
Just good comment on the AngularJS and Polymer. Now, I know the Angular team is getting influence from Polymer, and web components going to be the 2.0. Any good comment on that?
Yeah, there's a Angular library to import that will implement Polymer within it, and they're cross-compatible. So they're working together to produce living in the Angular world and kind of the syntactic expressions that you're used to working with.
Directive is going to be the web components and things like that.
Right. All right. Thank you.
Oh, that was you? Yeah. How you doing, man? How you doing?
Go out there.
All right. Oh, really?
Tag whatever the hell you want.
You got towels.
Yeah, I've never heard of it before. I don't do much in the web world. Oh, they do most of it. Yeah, well,
I wanted to ask some more questions.
Graduated college.
Yeah, well, cause like, I'm like,
I got a job.
yeah, it is. I just remember my last time about
I'll leave a
Yeah, this summer I just started, you know, like Michael and I started a company.
Like, I figured like after eating, you go upstairs.
Jack was in it. I don't know, he got kind of lazy. I don't know.
That's right.
It's fine.
I know he had a lot on his plate too. Yeah, that's cool.
We had to go upstairs.
Yeah.
You said that there's space somewhere else that's
Well, you are flying, buddy.
Nice. I don't know. How's it down? Yeah, so we just started on it.
I got a plastic cup of water.
And after a while, I just started putting on my resume because I thought I just.
I guess we are running out of time.
I know, I got a wife.
This goes over the shoulder, you know, whatever.
I don't like being too far away from like a computer.
So I applied
Andrew,
to
you forgot your shirt. Andrew. Andrew.
What? Oh, what? I know.
I realized how bad I was.
If and when I come back in here, I'll pick it up.
Work for super value now. You know, like cup foods.
I work at Best Buy.
And all that.
I do really boring work there.
I can show you the app. So this is a cup foods app, and we took it from this, and this is what I'm doing.
That's what it used.
This is what it's gonna look like. So it's weird. So if you, so something was weird on the apps, and we just started off because they're in testing. I was doing a bunch of stuff right here. I just came from work. I just wanted to see what's going on here. Yeah, I go to these a lot. Yeah, so the new one is, so this is when you start from scratch.
Yeah. Reactive. So
it's a lot better.
It's a lot.
This is how it's supposed to be. Yeah, so we have like coupons, you can select them, and
Every time we get something good.
yeah, you can it adds to your shopping list.
Someone who does not match ones that like, oh, you just got.
Yeah, these are all new things that just implemented, so you can just here. And, so we're just working on a bunch of stuff now. I think it's a good thing to get into.
So what language did you start off learning?
I started off with just Java.
Same.
Java's tough to start out with, but it's also I mean, you can do a lot with it once you understand it.
So where did you learn from? Because I'm just doing like Code Academy and like books that I find online.
Does Code Academy have Java, or are you talking about JavaScript?
JavaScript.
So JavaScript, okay, that's more like internet. So the web-based stuff, like Polymer stuff, that he's talking about.
Yeah.
It's kind of cumbersome. I never, like, as long as you learn one really well, then it's easier to go, or to other languages.
Yeah, I'm
I think
excited
also
about it.
just
I
plain
heard.
Java
I was
is
talking to
really
a couple
good.
devs.
It gives you a good basis.
have that
It's
are
hard to
really
start
good
out,
at
but
Yeah.
once you understand it, you can really go anywhere.
Because I was doing, they were saying that I did Java for like, I started off like a year ago. I just did Java like little intro stuff. And I was like, then I just didn't think much of it.
I don't know. Lloyd, do you know anything about that?